Good day, ladies and gentlemen. My name is Bongani, and today we are going to be learning series and parallel connection. So this video is a continuation of the series circuit and the parallel circuit. So you can check the link below if you didn't catch up on those videos, because in this one we are going to do the combination of the series and parallel connection. So without further ado, let's just get to it. So basically this circuit consists of a series circuit and a parallel circuit. So both the combination, both the series and the parallel circuit are both included in what? In one circuit. So we can say this one is R1, R2, R3 and R4. So here you can see that we have these two, R1 and R2, they are series. R3 and R4, they are parallel, but they are also connected into one circuit. This one is VT or VS. What you really need to note when dealing with a series parallel circuit is the current, because the current is the one which determines whether this one is a series circuit or this one is a parallel circuit. So that's what I want you to note very much when you are dealing with the series parallel circuit. For example, we did say that in a series circuit, the current is going to be what? It's going to be the same, but the voltage is going to be different in a series circuit. Then in a parallel circuit, the current is not going to be the same, it's going to be different, but the voltage is going to be the same. So this is very important when we are dealing with a series parallel circuit. So now when our circuit is closed, the current IT will flow in the circuit. And when the current flows, so this is how you analyze your circuit. You look at the flow of current, and if the same current is passing through two resistors or more resistors, that means those resistors are connected in series. But if the current is splitting, the resistors are getting different currents. That means those two resistors or those two branches, they are what? They are parallel. So for example, here we have IT flowing from our source from positive to negative. When the current flow here, we are going to get what? The current that is passing through R1 and the current that is passing through R2 is going to be the same. So what does that mean? It means R1 and R2, they are in series. But now when IT reaches this point, what are we going to get? The current is going to split when it reaches this point. It's going to split into two currents. Let's say this one is I1 and this one is going to be I2. So the current, when it reaches this point, it's going to split. And when the current splits, that means these two resistors, they are what? They are parallel. So how do we solve this problem? We have to calculate it separately. What I prefer doing, I prefer starting with the parallel first, then do the series, because after simplifying the parallel, then you can just add it with the series, which is way easier than starting with the series. So for example, this one we have to do the parallel first. So we have to say I parallel is going to be 1 over R3 plus 1 over R4. And then after you've got your R parallel, your circuit now is going to be like this. You're going to have R1, R2 and R parallel. And if you simplify this, if you calculate this parallel resistor using this one, that means they are going to be squeezed into what? Into 1 circuit. The battery now is going to see 3 resistors, 1, 2, and the combination. The combination of both is the parallel, so it's going to give you something that is series now. And if you have a series circuit, it's going to be simple to get RT. Your RT now, you just have to add it. It's going to be R1 plus R2 plus R parallel. You'll see how easy this is. Now, when you have to calculate, this was for analysis. The current was used for analysis. You didn't calculate it. You can do this even if you don't have the actual current value. This is just to analyze how the current flow in a parallel circuit. It is flowing here, is the same when it reaches this point, it's going to split into 2. So you are just analyzing, not that you need the actual value of the current, of the total current. So after that, you can calculate the total current, IT, which is going to be VT over RT. After you've calculated your total current, then you can continue to calculate. For example, if they want you to calculate the voltage here, you can use it now. For example, let's say we need to calculate V1. It's going to be IT, because the current is the same, times R1. For V2, IT R2. But now, if you want to calculate the voltages here, we know what's the voltage in the parallel circuit. They are the what? They are the same. But in a series circuit, the voltage, the resistor voltages, they are going to share the total voltage. So I recommend that you go and watch the previous videos which are on the link for the series and the parallel, so that you'll be able to grasp on what I'm talking about. So now we have the voltage here and we have the voltage here, which is calculated using the I total. We can simply put it into this form. We know what's in a series, in a parallel circuit, the voltages are the same. So we can simply calculate the voltage here, because the current that is splitting here, the combination of both them, they're going to give us the total current. So we can use V, let's say VR4 or V parallel. We can use IT times R parallel, which is this one. We come back here, because now they are in series. So if this is in series with this one, with R1 and R2, that means the current that is passing here is the same current passing through the parallel combination. So if we use the value of the parallel resistor, we can use the IT and the parallel resistance to calculate the voltage through here, because after getting the voltage of R4, we know the voltage R4, VR4 is the same as VR4 is the same as VR3, because they are parallel. Another way to do it is to calculate the current that is going to pass here using the voltage divider rule. So if we are using the voltage divider rule, then the current divider rule, you will be able to get this current I1 or I2. Then you calculate each voltage, which is going to give you the answer. So I'm going to put a link to a voltage divider rule, how to calculate the voltage divider rule as a whole. Please, you can go to that one so you can understand how to conduct the circuit using the voltage divider rule. So let's quickly get into an example, because I think the easiest way to understand this is by looking at an example. So this is our example. I want us to try to calculate the voltage VR3 and we're going to calculate the current and so forth. So let's quickly get to this one. Let's reduce it. I said we can first do what? Calculate the parallel circuit. Remember that one? So what we need to do, number one, this is I want to calculate the total resistance. So if we want to calculate the total resistance, let's start with the parallel. R parallel is going to be 1 over R3 plus 1 over R4. 1 over R parallel is going to be 1 over 2 plus 1 over 6. Okay, there is another way to calculate this, please. Another way to calculate this is going to be R3 times R4 over R3 plus R4. It's going to be 3 times 6 over 3 plus 6. So this is another way to calculate this. You can use whichever that you prefer, but they are both going to give you the right answer. The trick about this one is that this one only works when you have two resistors connected in parallel. Once the resistors are 3, then you can no longer use it. Only applies when you are calculating two parallel resistors. This one applies whether you are calculating 4 parallel resistor, 5 parallel resistor, whatever the number, this one applies. So I suggest that you master this one. So 1 over 3 plus 1 over 6 is 1 over 2. Then we cross multiply. R parallel is 2. So now our resistance is like this. We have R1, R2 and R parallel. We have 4, 3 and 2. Now RT is going to be R1 plus R2 plus R parallel. So this is going to be, so now it's simple. We are just going to add these resistors. It's going to be 4 plus 3 plus 2 and this 4 plus 3 plus 2, and it gives us 9. So this is RT. So that means we have answered number 1. The total resistor is 9 ohms. Question 2, what does question 2 say? It says calculate the total current. So 80 is going to be V T over RT, going to be 10 over 9. 10 over 9, 1.11 amps. IT is the current that is flowing here. It's going to 1.11 amps. So what does the question say? Calculate VR3. So now we want the voltage that is passing through the resistor. The resistor what? The resistor R3. Like I've said on our lesson here, that we can, since the voltage here, they are the same, so we can just calculate the combination, the voltage of the combination. It's going to give us the same answer, but I'm going to show you how to prove it. So the current that is passing through here 1.11 is the same that is passing through R1, is the same that is passing through R3, R2, and is the same that is passing through R parallel. Therefore, VR3 is going to be 1 IT times R parallel, which is 1.11 times 2. 1.11 times 2. This gives us 2.22 amps. Oh, sorry, volts. 2.224. So we can prove if this answer is right because we know in a series circuit, this voltage, the combination of VR1, VR2, and VR3, they must give us what? They must give us VT. So you can calculate on a side VR1, which is going to be 2 times, going to be 4 times 1.11, 4 times 1.11, 4.44, and VR2, 3 times 1.11, 3 point, going to give you 3.334. So the last one, the VR3, it was 2.22. So this combination, the addition of all these one, they must give us our supply voltage. So now you can calculate there on your side. VT 4.44 plus 3.33 plus 2.22. 4.44 plus 3.33 plus 1.11 plus 2.22. We are getting 9.99, which can be rounded off to 10 volts. That means your calculation is correct. So now, if you are to calculate your I1 and your I2, you've already calculated voltage, that is on R3. So we know what the voltage here is the same as the voltage here. So your I1 is going to be VR3 over R3, which is 2.22 over 3. 2.22, 0.74, and I2 is equal to 2.22 over 6. Gives us 0.37 amps. So this is your I1 and I2 is the current that is passing through here and the current that is passing here. So to prove this one, to prove that is the correct one, the answers are correct, they must give us this value, because this current is the one which came here and it's split into 2. That means this one, when it reached this point, it has split into 2, which means the addition of these 2, they must give us the total current, IT. Like I've explained about the jar, that when you have a jar, you take the water in a jar, you pour it into 2 cups, then the jar becomes empty. But now if you want to put back the water in the jar, you just take this one, you put it, then you add the next one, which is I2. It will give you the total water. So that's what we're going to do now to prove. IT, I1 plus I2, 0.74 plus 0.37, 0.74 plus 0.37, 1.11 amps. So that means we are correct. So ladies and gentlemen, I want us to continue. For this video we are done, but I'm going to post another video which has more complicated circuit, so that you will be able to grasp and understand how to calculate these calculations. Please click on the next video or the continuous video. You can check on the clip below, on the link that is below, where I have put the link for the next calculation, which has a more complicated calculation of a series parallel resistor. So for this video, I'd like to thank you for tuning in, and please have a nice day.